going to take here a look at slope intercept form of a line. We're going to start with some definitions and just taking a look at what is happening with this graph right here. So we have a graph and we want to understand what is all happening here. The first thing we're going to look at is what's called the y-axis of the graph. This is the vertical axis, which is this one right here. So this line right here represents the vertical axis or the y-axis of the graph. The second thing we're going to take a look at is what's called the x-axis. And this is the horizontal. And so we've talked about this in the past, where this is the independent variable, this is the dependent variable. And that is this one right here. Okay, so I'm just going to label it with the letter so we can see exactly what it is. We have our vertical axis or y-axis, and we have our horizontal axis, which is our x-axis. Okay, so the next thing that we need to put in, the next definition we're going to have, is something called a linear function. Okay, and with this is a line on the graph which can be described by any equation or by some function. And when we draw that out, it's going to be a straight line. So I'm just going to kind of pick 2 points here. I'm going to go over here, pick these 2 points, draw a line. There's going to be my linear function. You'll notice that on each side I put arrows, meaning that it keeps on going forever and ever and ever. So we have those arrows there, and this line is what we would call our linear function. So I'm just going to put a C there because that's what we have there. We'll have a function which will represent that line. Now whatever that function is should give us all the points along this line in nice and neat order. Next part here is the points which are on the line. Okay, so points on the line which satisfy the function. Each point is denoted by the coordinates. Okay, something x, y. Okay, so there's a bunch of different points we could have. So we have, let's see if we can find a nice point right here. There's a good point. So this is 0, 1. There's 1 point. I didn't draw a great line for this here, but this is another point right here. So this is the point 1, 2, 3, 4, 5, 6, 7, 7, 7. This graph symmetrical, 1, 2, 3, 4, 5, 6, 7, 7, 7. And here we have the point -7, -5. Okay, so there's different points. That point right there, these are all points along the line. Now we have a ton of other points. Okay, we don't have nice numbers for them, so we're not going to put in nice numbers, but we have a ton of other points that we could put in there. Okay, then E is the point where the function crosses the y-axis. So that's this one right here. Okay, we're going to put E right here. Okay, this is called the y-intercept. And it's going to have some sort of coordinates. In this case, it's 0, 1. It's one of our points. That's really nice. So 0, 1. So that is our y-intercept. It's where it crosses the y-axis. That's at this E here. We're going to call that E. And I'm going to just label these ones D. Okay, so you can see that as well. They're in orange. So you can see on my graph that they're a little bit different. Then the final thing is the point where the function crosses the x-axis. And you might already be able to guess, this is called the x-intercept. And again, it's going to have some value. It's right here. We don't know the exact value of this one. This one's a little bit tougher to find. Should have maybe drawn a bit of a better graph for that, but that's okay. And so that is our x-intercept, where it crosses over the x-axis. Now, the y-intercept and the x-intercept are the 2 points. Okay, this will be the point, let's say that's -1.1 and 0. Okay, so the y value is 0 here, the x value is 0 in this one here. So that's kind of the way that we can denote them with using a specific point in our graph. Then, just keep on going here. Now remember, you can pause this video at any time you want to kind of catch up, and then you can keep on going when you have caught up from that. So, slope-intercept form. Now, to determine what this line represents, or the function this line represents, we can use a function. And one of the ways that we can write a function is what's called slope-intercept form. So each linear function, or what we might consider to be a straight line, okay, on the graph like that, can be described by some form. Okay, slash function. Okay. So again, it's a function, but there's different kinds of forms that we can write it in. So if the slope is given, okay, remember we've looked at slope the last couple days, and the y-intercept is known, so that point right there on the graph, okay, then slope-intercept form, can be used to describe the graph. And for the next couple of days, we're going to take a look at slope-intercept form and how we can describe the graph using, or describe the graph in a function using this form, or using this way of writing it. So the way we write this out, and I'm just going to write out the form right here, is y, oh, black pen's given up here, y is equal to mx plus b, okay, where each one of these letters stands for something very specific. The x and the y, okay, are any point or any coordinate point that's on the line. Okay, so if we go back up here, any of these points could be put in for x and y. They could be put in for x and y. For the sake of this form, they will always be left as x and y. Okay, we're always going to leave them as x and y. We're not going to change that around. Now, the m, okay, if you remember m, it stands for slope. Okay, it's the slope of the line. We're going to leave it as a fraction or whole number. Decimals are not usually used. Okay, so we're usually not going to use decimals. We're going to try to keep it as a fraction as much as possible, or as best as possible. We're going to leave it as a fraction. The final thing is that b is the y-intercept. Okay. In the coordinate point, it is the y value. Okay, so it's the y value in the coordinate point right there. So that's what we're going to use as the b value. All right, so that's page 1. We'll move on to page 2 here. We're going to take a look at a couple of examples and how we can use our form to write things out. So the graph of a linear function has a slope 3 over 5, it's as a fraction, and a y-intercept of -4. That means that it goes through the point 0, -4, and it has a slope of 3 over 5. So we're going to write an equation for this function. So we know that y equals mx plus b. So this is our function here. And so we just insert this in for the m and this in for the b. So y equals 3 over 5x plus -4. And if we're plussing a negative, we can just write out as y equals 3 over 5x minus 4. And that is our function of the line. Now for the rest of the examples, please watch the next couple videos. And there's also a repeat of this one here that you can take a look through in a little bit more detail.